where we're going to go through these 40 questions through the least items. We're going to do this over a series of 2 parts. So do part 1 and then we'll do part 2. So here goes part 1 where I'll do screens 1 through 20. Alright, so here first it says which expression represents 4 less than half a number n. So 4 less than half a number n. Okay, so my answer should be right here, but in terms of doing my answer, I'm thinking 4 less. Well, first off, what's half of a number, right? Half a number. So I need half of a number, and specifically here it says half a number n. Well, now I want 4 less than half of a number n, so I want 4 less than this. So I need to take 4 away from it. Now, if you're ever not really sure, let's just put a number in for n. So let's make the n, for instance, here, okay, 8. So what if we said, which expression represents 4 less than half of 8? Okay, well, what's 4 less than half of 8? Well, we'd say, well, half of 8 is 4, and 4 less than that would give me a 0, okay? All right, so then you could then use that to then substitute them in here to see which one would make that work, okay? All right, let's go to screen 2. So here it says, which of the following binomials is a factor of this? So let's review how do we factor. So if I have x squared minus x minus 6. So really here what this is saying is, hey, if I need these, there's no number in front of the x squared. It's implied to be a 1. 1 times negative 6. I need two numbers that multiply to negative 6. And remember, no number here means it's implied to be a negative 1. So it needs to multiply to negative 6 and add to negative 1. So that should be negative 3 and positive 2. So from here, we would bring down my first term, x squared. We're going to pair that up with one of these terms. So I'm going to use the 2x. So I'm going to pair the 2x here. And then I'm going to pair, and again, remember, because we split the middle here. So now I've got the negative 3, so I'm going to do negative 3x. And then I've got the negative 6, so I'm going to bring that down as well. Then I'm going to take an x out of here for GCF, which leaves me with x plus 2. And then I'm going to take a GCF of negative 3 out here, and that leaves me with x plus 2. We know we're correct because these two match, so we write the x plus 2 one time, and then we write the two GCFs, which are x and negative 3, we write that for the other factor. So these are the two factors. But when I look at x plus 2, that's not one of the choices. So x minus 3, that is a choice. So there we go. All right, let's go to screen 3. So which one of these are simplified in simplest radical form? Notice this, though. It's really important. Select all that apply. So we can have more than one answer here. You don't want to just get to your first choice and go, oh, well, that must be it. Okay, so I'm going to start out with the idea that it's all of them. And then say which ones are already simplified. So when I see this x in here, remember, it's like how many times 2 can go into 1? Well, 2 can't go into 1, so I can't simplify this any further. And now I'm trying to simplify the square root of 2. Well, I can't simplify the square root of 2, okay? And I can't simplify, and I can't simplify the x or the y. So this one already is in simplified form. Let's look at the 50. So the question is here, can we break down the 50? So what about we need a perfect square that could break down 50, right? Well, what comes to my mind is 25 times 2. 25 is a perfect square. Square root of 25 is 5. So 5 would go outside and 2 would stay inside. So this can get simplified further, so we would take that choice away because it's not in simplest radical form. What about down here? Well, even the 12 can get simplified, but so can the x and so can the y to the third. Or sorry, the x to the third and the y to the fourth, because 2 can go into each of these. So this is not fully simplified. So both of these are the ones where we can't do anything else with what's in the inside, what's called the radicand, so they're already fully simplified. Okay, screen 4. So which expression is equivalent to this, okay? Now, we could do the for real actual workout, but again, we're focusing on the SOL and how do we actually get these questions correct. So what I would suggest is copy it, and then on the SOL, you will have your Desmos calculator. So copy it into the Desmos calculator and paste it. And then what I'm going to do here is I'm going to just set this thing, I'm going to set this thing equal to 0. So when I set it equal to 0, now I'm going to try and look at my graph. So here's my graph. And then what I'm going to do is I'm going to go down to each of these and I'm going to see, so what if the graph was x minus 6y, right? So if I go down here and I go x minus 6y equals 0. Well, that's not the same line. So therefore, this isn't a simplified version of it. So now what about x minus 2y? All right, well, let's try that. X minus 2y. Yes, it's the exact same line. So let's pick this. And now let's try 2x minus 4y. So 2x minus 4y. That also is the same line. So I would be thinking it could be both of these. Okay, we'll go over which one it has to be in a second. Let's prove the last one's not right. So 9x minus 6y. So I go here and I type in the 9x minus 6y. Notice it's not the same line. So actually, both of these gave us the same line. Well, what do we want? We want to show the most simplified form. So which one has the smaller numbers? Oh, the x minus 2y. Those are smaller numbers than the 2x minus 4y. So that has to be the answer. Okay. Now you could do the for real work where you multiply in, and combine all the like terms, but I just showed how to do it with checking with graphing. Okay. Which expression is equivalent to the cube root of 48? So we didn't really do these, right? We didn't really get into this. So what I would look at for which one is the expression is the simplest form. Cube root of 48. Let's put that into our Desmos calculator. Okay, when we do that, you see it's 3.36, etc. So let's go in here and let's try each of these. Well, clearly it can't be 16 or 24 because that's not what this is. So it has to be one of these two answers. So let's try them. All right, when I do the 6 cube root of 2, I end up with 7.559, which is not the same. So let's do 2 cube root of 6. When we do that, it's the same decimal. So therefore, it has to be this. Okay? So again, we're just showing that because we never actually broke down with cube roots. Okay? All right, so what about here? Square root. Now we can break down the 128. So I'll show it out, but then also show what if you don't know how to do it and what if you need to do it by doing it in the Desmos calculator. So if I was going to break down the square root of 128, the best numbers to use would be 64 times 2. 64 times 2, 64 is a perfect square, 64 times 2 is 128. The square root of 64 is 8, so that goes on the outside, and the 2 stays on the inside. So ideally, you could just do this math, you do this, and you get the answer. But what if you don't know how to do it? So you can still get it right. You go into your Desmos calculator, and we're going to basically do the same thing we just did on the last screen. So here's the square root of 128, okay, 11.31. Now I'm going to try each of these. So 8 square root of 2, which we know is our correct answer. Notice how it gives me the same thing. Now I'm going to try the other one. So 64 square root of 2, totally different answer. 4 square root of 8, same answer, but I'll go over why we wouldn't pick that one in just a second. 16 square root of 8, totally different answer. So obviously we can eliminate these. So now, since both these have the same decimal, you want to pick the one with the smallest number on the inside because it's the most simplified form. So that's how we get the 8 square root of 2. And that's how you could check it even if you didn't really know how to do the actual work. All right, screen 7. So which of the following polynomials expression is equivalent to this, okay? All right, this is a pretty tricky one, okay? So honestly here, I think a quick way to go through this, you'd need to technically factor in the top, and then you have this term on the bottom. What I would do is I would copy this, and let's use the Desmos calculator. So if I go in here, you go here. Now, the only thing is, the Desmos doesn't like n, so let's just switch all these to x for the variable. Alright, so now that we've done that, this is the line that we see. So now what we need is, let's pick out which one of these gives us those same lines. So we do 2n minus 3, okay, but again, remember I'm going to do x. Is that the same line? Nope. What's the next thing? 3 minus 2n, again, we're going to do it with x. 3 minus 2x, there you go, boom, on the line. Now let's try the other ones just to make sure. 3 minus 2n squared, again, we're going to use x, so 3 minus 2x squared, nope, not the same thing. And then 4 minus 2n squared, again, we're going to use x. So neither of those are even close. Boom, there's the one. So then we would just pick that answer. Okay. All right, screen 8. Which is a factor of this? So this is a challenging factoring question. You do have to go slow through it and know how to do the factoring. So 2n squared minus 5n minus 42. All right, so what do we do here? It's got to add to this middle term, which is negative 5. Then it's got to multiply to 2 times negative 42, which is negative 84. So you need to come up with two numbers that when you multiply you get negative 84, and when you add you get negative 5. So that should be negative 12 and 7. Okay? Alright, so then from there we're going to bring down that first term, and if you're not sure to come up with those numbers, you can check them in the calculator. Do 84 and start dividing. 84 divided by 2, 84 divided by 3 until we get to the numbers. Alright, we bring down the first term, bring down the last term. Then I'm going to pair my positive 7n in here. I'm going to pair my negative 12n here. Okay, I'm going to take out an n. So I go n and then 2n plus 7. Alright, and then I'm going to take out a negative out of here. And then I go, what's the biggest number that divides both into 12 and to 42? So it should be 6. So I'm going to take out negative 6, and then that's going to leave me with 2n plus 7. We notice that these are the same, so we're going to write that one time, and then the two GCFs form the other factor. Alright, so now I have 2n plus 7. That's not one of my choices. Now I have n minus 6. Boom, there we go. Alright. Number 9, so here we go. Which of the following is equivalent to this? So let's remember, what do we do when we're asked to divide with exponents? When we're asked to divide with exponents, we subtract. So 12 over 3 gives me 9. And now I have 2 over 6. Well, what's that give me? That gives me negative 4. But something we need to remember, you can never have a negative exponent. So the a to the 9th is fine in the top, but the b to the negative 4 needs to move to the bottom. So we get a to the 9th over b to the 4th. So a to the 9th over b to the 4th. Okay? All right. What is the value of the expression when n is negative 15? So you should get this correct. You copy it. You put it in Desmos. Okay? Remember, they hate seeing the n. But you can just hit add slider so we can get an answer. So now what does it tell me n is? N is negative 15. So just put a negative 15 in here. And what does it say? Negative 18. And that's it. Okay? So use Desmos to help you there. All right. Screen 11. Which graph on the left represents this equation? Again, you should get this right every time. You copy this. You put this in here. Okay, let's look at it. It goes through negative 5, 0, and 0, negative 4. So, and it's looking like a downward slope. So which one does that? So notice this one is the only one that's anywhere close, so that is A. All right. A formula to find an angle measure of an isosceles triangle is shown here. Which equation can be used to find x? So what do we need to do? It gives us this formula. We need to solve for x. All right. So let's go through and do that. So to solve for x here, I'm going to start by minusing y to both sides. So when I do that, I'm going to get 180 minus y equals 2x. Now I need to solve for x. So I'm going to divide by 2 here. So I'm going to get 180 minus y over 2 equals x. Okay, 180 minus y over 2. Well, which one's that? There it is, right there. Okay? All right. All right, here it says, which equation represents the line that passes through these points? So here's how I would do that. I would go into Desmos. I see the point negative 4, negative 4, 4. So I'm going to type that, negative 4, comma 4. Boom. And let's label it. And then let's do 8, negative 2. So then let's do 8, negative 2. And let's label that. Okay, now what I'm going to do is I'm going to try each of these lines and see, when I graph it, does it go through those 2 points? So, no. It goes through one of them, but not both of them. So what's the next one? Negative 2x minus 4. Nope, goes through this point, but not the other point. Boom. Goes through both points. Now, me personally, I like to just double check, try each question just to make sure. Nope, doesn't do it. So it has to be that third answer. All right. All right. For which of these inequalities is negative 3, 1 a solution? Okay. Okay, so if negative 3, 1 is going to be a solution, let's do the same thing. So get rid of this, get rid of this. Let's change this to negative 3, 1. Okay, now what do we need to do? We need to plug in both of these. So I'm going to put these in. And remember, this is two inequalities. So that's what we call a system of inequality. So it needs to be in the shaded region for both. Okay, so everybody see this? This is a dotted line. So it's a dotted line. It cannot be on the dotted line. So I don't even need to do the other side. I know it can't be an answer here because it's on this dotted line. So therefore, I can just skip into the next problem. Now, that was my x plus y was less than negative 2, right? Well, that's the same thing here and here. So neither of those are going to work. So what I need is to make that a solid line, right? So it's got to be one of these two answers to make that a solid line. So now let's change this to a less than or equal to negative 2, because that's what it has for these bottom two. Now look, now it's on the solid line, and that works. So it can't be either of these top two, it's got to be one of these bottom two. So now let's try one of the lines, see if it works, and if not, we try the other one. So we go down here, we're going to put this in, boom. Okay, that's on a solid line, so now that works. If this was a dotted line, it would not work. Both lines have to be solid. So the only one of these choices that has both of them as solid lines are the ones that have the or equal to for both, which is this bottom choice. All right, what is the solution to this system? Okay, so what we're going to do here is we're going to copy these. Remember, system of equations means we want to look at where they intersect, but there's no shading. So we type this guy in, then we copy and paste this one. We put them both in here. We look for where they intersect. 1, 5. That's my answer. Okay. Question 16. It says, here's the graph here. Okay. What are the solutions? So the solutions are where we cross the x-axis. So they're here and here. And that's it. Right? It said to mark the solution. So you'd click on it. Like this could be one of those technology items. You have to click on it. It's just those two. We don't care about the y-intercept. We don't care. Just what are the x-intercepts. Right? If it asks you what the solutions are, you'd say they're x equals 2 and x equals negative 4. All right. Here it says, what value of x makes this equation true? Okay, so you should do all the work out to get it, but to actually get this answer, let's just go in here, plug this in here, and click. We see how it says 4, so my answer is 4. All right. Which equation best represents line M? Oops, sorry. All right, so again, you should be able to get this just from here. Oh, that's a y-intercept at negative 4, which all of them have, and let's count the slope. Here's another point, so what do? We go up 1, right 1, 2, 3. So we need up 1, right 3, which is a 1/3 right here. But what about it's on the test? Shouldn't you do this? Shouldn't you go into Desmos and check it? 100% check it. So you go in here, and then you make sure, do these points line up with what you see from here, and double check that they line up and match. All right, here we go. So Christopher incorrectly solved this. Here we're going to have to actually go through and do the work, right? Because it says, between what two consecutive steps did Chris make a mistake? Okay. All right. So what should he have done here first? He should have minus 1 to both sides. So that looks good. But then what's the next step? Once we minus 1 to both sides, we're going to multiply in here, multiply in here. So that looks good. Then we're going to minus the 32, or sorry, minus the 28 to both sides. That looks good. But when we get to step 4, you've got negative 4x is less than or equal to negative 32. Well, we need to divide both sides by negative 4. When we divide by a negative, you must switch the sign of the inequality. So his error is between step 4 and 5, right? All right, so there we go. All right, last but not least for this one, solve here. So again, you should be able to do the math out for this, but in terms of just getting it right on the SOL, we go in here, we copy it in here, we put it in here. Remember, Desmos doesn't like anything other than x, So just change these to an x and then click on it. You get negative 17. And so then that's your answer. Okay? N equals negative 17. All right? All right, this is the first half of the Desmos practice test, and then hope this helped.